Next we have here is central limit theorem. Okay, so central limit theorem states that the sampling distribution will adhere to these three property regardless of how population is distributed. So the sampling distribution, which is essentially the distribution of sample mean of the population, has some interesting property, which is population mean should be equal to sampling distribution mean. Second is the standard deviation of the sampling distribution is equal to n, where n is the sample size and the standard deviation of the population. That is what sigma at the rate means. Okay, and then third distribution, or you can say the third property, is the distribution changes to normal distribution when n exceed 30. So basically what I mean by that is, if you have at least 30 record, I mean at least 30 and or greater than 30, that means that particular number of row will give you a normal distribution. That is the third property of central limit theorem. Okay, so let's understand it with an example. Okay, so as you can see, there is three columns here. First column is uniformly distributed, then you will come to like this, and then normally distributed like this. Also, like I said in the previous video, in real life you will not be going to get a normally distributed data. So first it will be most likely that you will get like this or like this. So you will be doing some fixing standard uh, formula you will be applying, and then later on before going for modeling, you have to make your data like this, I mean moreover, and then you will be doing further things. So so apart from the example, let's so what is the problem in central limit theorem? So how can you be sure that the inside inferred from the sample hold true for the population as well? That's the main problem we have currently, right? So in other word, just because you know so first let's assume that we have a survey that revealed 49% of respondent favor feature B over feature A of based of a Facebook company that created a new feature. So Facebook can claim that feature B should take the place of feature A because it is more preferred by more user. Okay, so as a result, Facebook discovered through sampling that feature B is preferred by some users than the feature A, and it saved time, money, and risk associated with the rolling out, or you can say conducting the exercise on sampling rather than population. So as you can see, Facebook has saved so much money, right? But hold on, that is the catch that I was telling. You can't be sure. Okay, you can't be sure the insight that is came from the mean will hold true for the population. So in other words, just because 50.5% of the people in the sample prefer feature V, it is not fair to say that 50.5% of the people in the population, that is like 1.9 billion Facebook user, will also prefer feature B over A. Okay, and why I mean we have to be sure about this. We will be learning that in confidence interval. Okay,